Hello everyone, my name is Christina and I would like to welcome you to our online meetup. Very happy that you joined us today. First, let me tell you one very important thing. I hope that you and your families are safe and sound and you are making... Hello everyone, my name is Christina and I would like to welcome you to our... I'm sorry? So I hope that you are all making all the necessary precautions to make this situation pass as quickly as possible. Before I will give a stage to Jill, I would like to say you two very important things. The first one is, if you have any questions, please write them into our live chat. We will go through them after the talk. And the second one is that even though we are having an online event, we wanted you to have the same advantage of attending an offline meetup. So we have created a Slack group in which you can continue in discussion, ask questions, and be in touch with the community and the speaker. We will send the link to the Slack community in a few moments. So please feel free to join it and also drive the discussion there. So that's all from my side. Now I would like to give a word to Jill, who will tell you something about microservices and testing. So Jill, the stage is yours.
Thank you. Okay. Hi, everybody. From my home, I'm hoping everybody is staying safe at their house. Because I am at home, my hair isn't getting any shorter, so excuse me for the appearance. And if my cat suddenly comes walking over, well, we'll excuse her, and there's nothing we can do because cats. Anyway, this is the original song. These boots were made for walking, and that's just what they'll do. One of these days, these boots are going to walk all over you. I took the liberty of changing the lyrics a bit. These microservices are made for testing, and that is just what we'll do. One of these days, these tests are going to help a lot to you. And this is exactly about that, about how to test microservices. And not only will we talk about testing microservices, I will live code a test for microservices on stage. And people love live coding, and I've always asked myself why. And I think the answer is, it's like the arena in the gladiators in Rome. People really want the lion to eat the gladiator. So people really want me, and during the live coding, to fail spectacularly. I hope it'll be good. We'll see. We have a link to the GitHub repo and to this presentation here. You will get it in the last slide, and it's on YouTube, so you can look whenever you want. Feel free to take the GitHub repo. The GitHub repo includes all the code we will be seeing in this talk. Okay, a little bit about me. I go back all the way back to the 80s. I'm really old. I did the startup thing and founding a startup and being the CTO and all that. Didn't really like it. It was interesting, cool, but didn't really like it. It seems that I am a developer. I was a developer, and I probably will be a developer till the day I die. I love testing code. Testing the code I write. It's my passion. I've been doing it since about the year 2000, maybe even a little earlier. And because I love testing, I am currently a developer relations and an architect, a software architect at Applitools. What we do is we deliver visual testing tools. So if you're a front-end developer and you want to test not only how your application functions, which is what things like Selenium and Cypress are, but also how they look like, that they look the same as they should, then go see our applitools.com site and check it out, or you can contact me sometimes earlier. Okay, so I'm not going to talk about what are microservices, but just a baseline, just so we understand what we're talking about. There are a lot of talks about microservices online, but here are the basics. First of all, they are web apps, just like regular, front-end facing web apps, but they're back-end facing. They only work on back-end. A microservice architecture is an architecture where instead of one big app, one big web app, you're taking that one big web app and making it into a lot of small web apps, and they all communicate with each other. How do they communicate? either via HTTP. So if I wanna call something from one web app to another, I do an HTTP and send over JSON or a GraphQL query, or put a message in a message queue. The other app reads it, puts in another message, etc., etc. The most important thing about microservices is that they are independent. So each microservice has its own code, does not share code with others, can be deployed separately, and the most important thing for us, tested separately, and that's the most important thing. So it's compiled, built, and deployed separately, and that is its most big advantage. Why? Because if you have a large product with lots of teams, each team can be responsible for a set of microservices, and they can do whatever they want there. They don't have to synchronize with other teams because they can compile, build, and deploy their microservices independent of their other teams. But unfortunately, that comes with a price. Because they're not allowed, they have to be independent, they are not allowed to share data with other microservices. That creates a lot of complications. I do not want to go talk about that, but there are a lot of talks about that online. So a good example is what I'm working on the Applitools. It's called the Applitools Visual Grid. And the idea is, and just a quick idea, is instead of taking a screenshot of the app like a PNG, what we do is we take the DOM snapshot. We take the HTML, the CSS, the SVGs, the fonts, whatever, upload them to the visual grid, and then recreate the page. And we have like thousands and thousands of browsers: Chrome, Firefox, Safari, IE, whatever. Recreate them in those browsers, take the screenshots, and then push them to our server where they can be diffed and checked and managed and all that. So we can parallelize, instead of taking one screenshot, we can parallelize and take like 10 screenshots in different browser configurations all at the same time. How does this work? Our SDK, instead of taking a screenshot, takes all the DOM snapshot services, the HTML, the CSS, the SVGs, the PNGs, etc., and puts them to our snapshot server where they are stored in the cloud. Then it posts a render job to the rendering API. Please render the snapshot that I just sent you in Chrome 1024 or in Firefox 1024 or 1280 or whatever. The rendering API, that is a microservice, and the snapshot server is also a microservice, and they are totally independent. Uploads, submits a job to a job queue. And the workers, we have workers for each browser: a Chrome worker, a Firefox worker, an IE worker, etc., Safari worker, takes the jobs from the job queue and sends them over, navigates to a certain URL in the headless Chrome. So the worker includes both our code and the Chrome browser itself in headless mode. The URL is a URL to the snapshot server to get and recreate the page. The snapshot server generates the HTML that is used to recreate the page. Once we have that page in the browser, we just take a screenshot and boom, we're done. Then the important thing is not understanding the visual grid, it's understanding that here we have 4 separate microservices, and in the case of Chrome and Firefox, we have a lot of instances of those microservices, and each one is compiled, built, and deployed and tested independently of one another. And the most important thing for us is that they are tested independently and that they aren't huge. Each one of these microservices is doing one task and one task only, so they're not huge in terms of amount of code. Okay, we've understood microservices. Let's talk about tests. Why do we write tests? And we have 2 answers for that. One is because we have to, and because we don't like doing manual testing. So every time we change something, we don't want to manual test it. But why do we test at all? And my answer is, and I'm sorry for people who saw my talk at Reactive, this is like a very quick summary of that. My point of view on why is, I call it 𝗚𝗜𝗟'𝗀 What is 𝗚𝗚𝗟'𝗀? It's fear of my code. Okay, I know that I fear my code. The code that I write, I fear it. And why do I fear it? Well, when we add code, we always think of it as a Lego thing that you just add, but we all know the reality. The reality is once we add code, everything breaks, or a lot of stuff breaks, or sometimes it doesn't break at all, but we don't know. So every time we add some code to our application, We fear adding that code. Removing code is supposed to be the easiest thing possible, and nobody's using that CSS rule, right? And we've seen that a lot, but we all know what happens a lot of times when we remove code. Yes, it was used for something. And refactoring, we all want to refactor, but we're really, really frightened because we know how the refactoring starts, but we never know how it ends, just like this poor kitty. It knew how it starts, it didn't know how it ends. So, and it doesn't really matter if our code is really, really nice or it's really, really ugly and spaghetti, we fear changing it. It doesn't really matter because adding, removing, or refactoring code is a change, and that change breaks stuff. We can't avoid it unless we're total geniuses, and nobody is. And testing is what stops ego programmophobia. It's like the pill that you take to remove that fear of your own code, because you write your tests, okay, add your code, run your tests, they run, perfect, we're good, we can deploy. They don't run, we fix the bug, and then deploy. Okay, so we talked about microservices, we talked about testing. Let's do stuff. Let's live code a microservice. And I chose a really simple microservice. I mentor some people on my own spare time, some junior developers, and we're building this building application where you have tenants of the building, people who live there, and they have to pay rent and all that stuff. So it's the microservice I'm talking about is very simple. It has a CRUD interface to a tenants database. We're using Postgres, and you can add stuff. It has an API, a REST API, where you can add a tenant, delete a tenant, update a tenant, and list all tenants. Classic CRUD. Okay, we're going to live a test, not the microservice itself. The microservice itself is written, but let's look at it. Okay, where are we? Okay, this is the code, and it's, as I said, it's in the GitHub repo. You have the link, and we'll put it in the comments later. I like to separate my source and my tests. Some people like them together. It's just a matter of opinion. Let's start with a Docker file, because a microservice is usually really served by Docker. I don't want to get into Docker. It's a whole thing. But in the end, what is important is that the entry point to the application is run microservices are made for testing. Okay, so it's this one. Okay, so let's look at the app. Sorry, no, it's this one. It's this one. Let's look at the main. This is the main. This is what is running. What it does is it calls create app to create an app. If I was using Express, then it would be creating an app, an Express app. But I'm using Fastify because Fastify is much better and supports promises natively. So please stop using Express. Use Fastify. So create app will create that app. It's not yet listening on a port. It's just creating that app. And we'll talk later about why we're doing that. Then we're taking the port, okay, and listening on it. But notice two things. When we're creating the app, we're sending it the parameters. The parameters in a regular microservice is mostly sent via environment variables. There are other ways, but mostly. So what this code does, it just takes the environment variables and sends them to create app. And if you think of create app is devoid of any thought about environment variables or whatever, and that is very important for testing. We'll talk about that later. And then we listen, and notice that we listen not in the create app. Why am I going on about that create app? Because that create app, that is what we mostly test. We don't want to run a process or run a Docker instance to test it, because that's heavy and that's very difficult to debug. What we want is just to get the app, listen on it, and boom, we have a running app. So this is, we mostly won't be testing this function. What we will be testing is the create app. Create app is an SRC, and it's our main entry point to it. And it's getting the database connection string, as we said earlier. When it's running in a Docker container, it will get it from the environment variable because this, right? But if we want to send another database connection string, that's fine. We create a Fastify application. We connect to the database, okay? And then we define routes. / returns a health check, API tenants gets the list of tenants, etc., etc. I want to talk about that retry because, again, that's important for testability. Why do we need to retry a connection to database? In production, that database is always there. True, but not in the tests. In the tests, sometimes the application runs quicker than the database. So that when we're running the test and running both of them, the app database, the app isn't ready. The app is ready and it wants to connect, but the database isn't ready. So we retry. Another example of when things have to be testable, we change the application slightly to be testable. Okay. Oh, and I'm using the wonderful P retry from 𝗧𝗔𝗟𝗧𝗧, and I hope I'm saying it correctly. Okay, so we're using a simple query. Okay, first name, last name from tenants, and we're transforming it into first name in camel case using SQL row to objects. We're returning an array of tenants. Let's talk about adding a tenant. We're posting. When we're posting a tenant with an ID, then we insert it into the database. And basically, that's the app. It's not that difficult, okay? And we connect to the database. We saw the code. It's just Postgres code. I'm using the regular Postgres client. But notice something else. I'm exporting the database schema. Why am I exporting the database schema if I'm not even creating the database? It's the DBA's work to create that table, right, in the database. And again, the answer is testability. In the test, I need to create the database schema, that table. I don't want it to be in the test code. I want it to be close to the production code. So I put it here, even though it's not really necessary. So another testability issue. Notice the interesting thing, this has nothing to do with microservices or testing. I'm using the new capability of Node.js to use import and export. Native import export. I'm not transpiling anything. This is pure JavaScript, and it's a replacement for CommonJS for require in Node.js. I'm a huge fan of Node ES modules. Did a talk about that. So I decided to convert from CommonJS to Node ES modules. I wanted to convert this application, and it's working. Woo! Okay. So that is the app. Very, very simple app. Notice things, the testability. One, I'm separating the running and the getting of the environment variables and the listening from the main core of the app. Two, I'm retrying the connected database because in tests, I don't know which is going or which goes up first. And three, I'm exporting the database schema because tests need that. Okay. So let's see if I showed everything. The REST API and its implementation using SQL, the retry connected to the database, data schema, and separation of app and running app and configuration as NV variable. And those three are testing related. Yay, I've shown everything. So what will we be writing? We will be writing unit tests, integration tests, and end-to-end tests. Those are the types of tests we'll be writing. But no, we won't be writing unit tests. There are tons of information about writing unit tests. Everybody, when they start talking about unit tests, they start with unit tests like add. You know, everybody just takes a function like add and tests it for all the various use cases. I don't want to talk about that. We'll talk about how much unit tests we need and everything in the end, but let's ignore that for now because the most important thing is integration tests. How do integration tests work? First of all, we run the server, our web app. Okay. Then we run all the services it depends on, the database, the message queue, whatever. And how will we do that? We will be using Docker Compose. Docker Compose can run a lot of Docker containers. So if I'm using Redis and Postgres and a message queue and everything, I can put them in one Docker Compose file and just run that. Boom. And this is wonderful. It changed the whole way we think of integration tests in Node.js and other languages. And Now we've done the setup. Now for each test, what we do an HTTP call to the web app, okay, to test. Let's say I want to test add tenants, so I HTTP for add, and then I HTTP for lists to check that the list of tenants has added that tenant and check that it works correctly. In the end, we tear down the server and the Docker containers and all that. That's basically how integration tests work. Let's see an example. Okay. Let's see an example. End-to-end tests. All my end-to-end tests are here. Okay. There we go. So first of all, I use a library I built back in the days called Docker Compose Mocha. It has nothing to do with Mocha, but anyway, bad name. What it does is it gets the name of a Docker Compose file, in this case, this Docker Compose file, which has just one container in it, the Postgres container, okay? And the various environment variables that the Postgres container needs, and runs it. And in the before, runs the Docker container, and the after kills the Docker containers. This is very cool. Not only that, it has this cool effect where in the next time you run it, maybe there are like rogue containers from previous runs, so it kills them also. Anyway, that's what I run. Oh, there's a cat. First of all, in the before, I prepare the database, which is create the schema. And in the before each, I reset the database, which is clean all the rows from the tenants table. We'll see that in a second. And then in the before, I set up the app. What does setup app mean? Come on, click. There we go. Setup app. I get the address of Postgres from Docker Compose. It's not a specific. Every time the Docker Compose tool runs, I get a separate address. It's not a specific address. Why? Because I may have multiple tests running and I don't want them like interfering with one another. So every port is random. Then I create the app and give it the connection string it needs for Postgres. See, I've just created the app just using a function call. And then I listen. On what port? Port 0. What is port 0? It means get me a random port. I don't care what it is. Again, all tests, microservice tests, should use random ports, because if you want to run them in parallel, and you will want to run them in parallel at a certain time, you don't want them interfering with one another. So that's the setup. And then let's look at the test. Let's see. It should return tenant after it is added. This is a test of adding a tenant. So we, create a tenant with a random ID using UUID, first name Tayar, blah blah blah. And then we add a tenant. I'm using my nice library, HTTP Commons, which is a very, 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 there it is, very small wrapper above node fetch. And what it does is, in this case, it uses this URL, fetches a JSON, and posts this JSON to it. So this will basically add a tenant. Notice the base URL here. The base URL, I get the address from the app instance I created earlier, appinstance.server.asterisk.port. So this is the port that was created randomly by the setup app, if you remember our app port. Okay, and then I just, post it. That adds a tenant, and then have to check. I fetch the list of tenants, and boom, I check that it's equal to tenant. Let's run just this test. Hit done only. And I do npm run test mocha. I don't want to run all the tests. Just the mocha test. See, it's running the Docker Compose, and boom, we're passing. Great. Okay. Now we've shown the example. Let's live code an integration test. Ooh, this is the part with the lion. Okay. Delete a user. Okay, this is what I'm going to test. How do we delete a user? First of all, let's see how much time do I have. Okay. First of all, I create 3 users. Okay. And then after a while, write the code in a sec. I list the users. Not users, sorry. Should delete the tenant. Oops, sorry. Create 3 tenants, list the tenants, and then check whether the only tenants are the last 2 ones. Oh wait, I didn't delete. Create the 3 tenants, delete the first tenant, and check whether the only tenants are the last ones. Perfect. But notice we have create, we have add, and we have list. And it's really, really not nice that I have to write this whole thing. So let's do some refactoring, because Visual Studio Code is really cool about this. So we take all this, we command dot it, and I say instruct a function, boom, and we'll call it add tenant. Yay! Now the base URL here is a function, so I'm gonna, munch it a little bit. There we go. And I have add tenant here. And let's do the same for list. Let's do the same for list. And we'll extract a function, list tenants. Remember, your test code is almost as important as your production code. Keep it nice and clean. Okay, base URL, and here we'll pass in base URL. By the way, why is base URL a function? What happened here? Oh, sorry. Why is base URL a function? Because I don't know beforehand what the port is, so I can only calculate it lazily. It can't be a const address. I can only calculate it lazily. Okay, let's do it like all stuff. Because we really like nice code. Okay. Should update the user. Okay, wait. List tenants. Base URL. Okay, list tenants. There we go. As long as we're here, let's do the update also. Extract to function, update tenant. Oh, now we'll do the thingy, refactoring, and wow, the code is much nicer. Look at it. I can even remove the comments. I'm not a huge. We didn't do an add tenant here. Add tenant, base URL, and tenant. We can remove the code comments. I'm not a huge fan. Nice. Okay. This has nothing to do with testing. It has actually. When you're testing, write clean code. That is very, very important. So let's create 3 tenants. So let's first of all create the tenants, const tenants equals, we'll do an array, we'll take me as an example. Okay, and my wife with Abraham. And a good friend of mine who is very much into microservice testing. He's also a consultant. So if you're a company who wants to dive deep into microservices testing and needs a consultant on that, go talk to him. He's wonderful, and we have like similar views on microservice testing. Okay, so we have the tenants. Now we create add tenant base URL. See how nicely it auto completes, and tenants 0. Create 2, and we've created 3 tenants. Perfect. But I don't like this. Why are we doing this serially? We're in Node.js. It is so easy to do it using promise.all and do it in parallel. Woo! That makes our testing so much faster. feels faster. And boom, oh no, what did we miss? What did we miss? There we go. If you're asking the way, auto indents and everything, I'm using prettier, and the prettier, so it just, makes it prettier every time. I don't need to indent myself. This is great. But we can do better, because look, it's going through the tenants, and we have the tenants array. So let's do this. We map, okay, and we say on each tenant, add a tenant. Add tenant base URL tenant. And boom, we're done. Isn't Node.js wonderful? It's so easy to parallelize stuff. It's like magic. Okay, so now we delete the first tenant. How do we delete a tenant? We take HTTP comment and we fetch fetchization. We post a JSON body, but the API is where is it? It's with the tenant ID. Okay. Okay. There we go. But we have the first tenant. We'll use the first tenant. And we post whatever. It doesn't care what it has in the body, so we're posting like a regular nothing. But we don't want to post. We want to delete. So we say method delete. This deletes the tenant, the first tenant. Okay. Now we list the tenants. We can copy paste that because we are copy pasting people, and we'll copy paste the expect to, and we expect the list not to equal that list because we don't know what order we're getting it. So to have members, which members? We want the tenants from the first, from the second, but in zero index it's the first. So we take the second and the third as an array. So we want it to have members, and because we want, this is 𝗓𝗓, we want the equality to be deep equality because we're comparing objects. So we want it to check out the whole thing. So that's it. So we added the tenants, whoosh, and we deleted the tenants, and then we list the tenants and expect them to be only these last two. So nice. Will this work, or will the lion eat me? Okay. npm run. I'm testing only this. And, oh. No, it didn't work. Good, the lion ate me, but it's just tickling. Oh, of course, base URL. Okay, let's run it again. Lion, I fear you not. Yay, the test passed. Notice the 47 milliseconds. That, yes, running the Docker took some time, and that's the setup time, but the test itself ran really, really quickly. Let's make it run like 100 times. Array 100.fill1. So this creates an array, and then we're going over it and doing it only 100 times. Let's see how fast it is. So we're running the test of delete 100 times. That is including deleting all the rows. Look how fast that is. That is crazy fast. Most of the tests are running under 40 milliseconds, okay? Like half of them. So you can run hundreds of tests and have these tests pass in seconds. So don't be afraid of integration tests. You don't need to go all the way into unit tests because you need things to be fast. Integration tests are really fast as they are. Remove that and remove the dot only, and yay, we have just finished. But because I want to be nice, I want to extract a function, call it delete tenant, and pass the base URL, command click, and no base URL here. But I don't want all the tenants. I want to pass a tenant, specific tenant and take its ID. Tenant ID. And here I want to pass tenant 0. Tenant 0. Oh, let's run all the tests. Okay, in unit, end-to-end, everything. Okay, just a sec. That's good. Yay, all the integration tests passed. We'll talk about end-to-end in a sec. So yes, woo. The lion did not eat me. Okay, so we saw Docker compose.yaml. We saw how to set up the DB. We saw the Applitools, Docker compose Mocha. Feel free, it is open source. You can use it. Get address for service, because we don't know what the Postgres server address is, because we want to make it random every time we run. So we get the address from Docker. Prepare the database. We didn't see that, not very important. Reset the database just deletes all the rows in the table, because I want each test to start fresh. And then set up app. And that's nice, because remember that microservice where we create the app? The nice thing about that is if we have a test of another microservice and it wants to use this microservice, it doesn't need to get it as a Docker container. It can just declare a dependency on it and just create the app itself, make it listen, and that makes the two microservice testing really, really easy, because you can just require the two, connect the dots, boom, you have a mostly end-to-end test without running Docker at all. Okay, and we saw how fast it is by running tests multiple times. Perfect. Live coding and end-to-end. We're on it. Okay. Now, why do we need an end-to-end? What do you mean end-to-end? It's just one microservice. And the answer is, this is what we call the little end-to-end test. We've tested the app, but we haven't tested it inside a Docker container. And we didn't test the run code and the environment variables and all that glue code. Yes, we know that most of it runs, but how do we know that it runs in a Docker container? You don't need to run all the tests. You can just take one of the integration tests and see if it works in the Docker container. Okay? No, not this one, sorry. We'll use this one. Okay, so we'll do the add test. It's the simplest, and it will test whether we test. First of all, we need to build the Docker, our Docker container. So the Docker container is built. And now look at the Docker compose the end-to-end test is using. It's running Postgres, but it's also running our app itself. See? This is the name of the image that we've just created. 𝗬𝗓𝗏 /microservices are made for testing, and it's sending the Docker, the Postgres connection string as an environment variable. Okay, so that when the Docker container runs this code, we get the environment variable, and the app gets the connection string. Perfect. Okay. Okay. Now, what do we need to do here? One, add a tenant. List tenants. Check that the tenant is there. Perfect. But we have this. We have those, but they're here. No, they're here in the integration tests. So what do we do? Look, they're perfect. They get a base URL and everything. So what do? We Visual Studio Code refactor it and move it to a new file. Whoosh. It creates a new file. This is really cool. There we go. It didn't work. Let's do it again. It worked on my machine. Okay. We moved to a new file. This time it worked. Here it is. It's called delete tenant. That's really bad. We'll call it tenant ops. And look what it did. It gave me a require that I don't need. That's fine. But it imported whatever I wanted to import, and it copied everything I need here, and it added an import here. Woo! This is amazing. I need to add a .js because in Node.js modules I have to add the extension. And then I move it to commons because I want it also an end-to-end. And it, you know, rewrites everything, but it rewrites it badly because Node.js. Oh no, it worked. Perfect. Okay. End-to-end. Now I can do the end-to-end. I will import. No, sorry. I will import from what was that? Commons /tenant.js, and I will import add tenant and this tenant. Perfect. Add a tenant. Oh, okay. Add a tenant. So we await add tenant base URL. What is the base URL? We'll talk about that in a second, and we'll add a tenant. Oh wait, I forgot. I need a tenant. Here's my regular tenant. There we go. Perfect. Oh, I need UID. There we go. Okay, now we list tenants. Again, I don't know what the base URL is. Just a sec. List tenants, base URL, and I get tenants. And then we expect tenants to equal exactly tenant. An array with one. What's this const doing here? Perfect. Now we need the base URL. Okay. First of all, remember the app is running in Docker Compose, so I need to ask Docker Compose for that. So I use DCT. Okay, and another, and I use await DCT dot, oh no, completion, get address from service. I don't remember. Okay, get address for service, and it needs the env name from the Docker Compose tool and the compose path, and the name in the Docker Compose, that's app, and the port it exposes is 80. So now I get the app address. That's just the IP and the port. The base URL is HTTP $app address. Yay. Perfect. And we have a test. We have a tenant, we got the base URL, we add a tenant, we list it, and we check that it's the correct one. And let's it.only, so we can test only that. And npm run test mocha, lion, where are you? Yes, it passed. By the way, is it passing? Let's change something. Okay, so that it fails. By the way, every test I run, when it passes the first time, I check, I make it fail just to see that it's not passing always. Okay, perfect. It failed as it should. Now we can run all the tests. npm test npm test. And boom, it's running all the tests. Oh no. Oh, prettier. In the test, I'm also checking if the prettier is okay. I do this, run it again, and running all of them. Okay, will all the tests pass? Will all the tests pass? And there we go. Yes. Woo! Yes. Show. And we built the Docker image. We showed the Docker file previously. We talked about the Docker Compose. Oh, never mind. And npm test. Oh, we're not using Mocha parallel test anymore. Anyway. Okay. Testing strategy. We've seen how to live code. We've seen that it's not actually very difficult if you have the correct pieces of the puzzle, which are Docker Compose or Docker to run the services like Postgres. If We separate, the taking of the configuration from the creating of the app and the listening, and then you just HTTP and check, HTTP and check, HTTP and check. It is that simple. Well, unless microservice is a difficult one to test, like lots of queues and lots of things, but that's okay. That's not accidental complexity. That is real complexity, and there's nothing we can do. But in terms of accidental complexity, there's not a lot. Okay, and why is this different from monolith testing, from testing a huge app with like hundreds of thousands of lines of code? And the answer is because a microservice is small. Integration tests do a great job. Okay, they run fast, they're easy to do. There's not a lot, so no really need for a lot of unit tests. Okay, you don't need to mock everything and do lots of unit tests because your integration tests are very quick, very easy to write. Code is simple. Not a lot of data is set up. And if a test fails, it's usually fairly easy to see why. If you're doing a monolith and you're doing integration tests where you're checking a lot of the application together, it's very difficult to test, very difficult to set up, and very difficult to see where the bug is when the test fails. But in microservices, because they're fairly small, everything is perfect. What about unit tests? Just throw all of them away? No. Unit tests are wonderful. And use them for mostly pure logic, like functions that input, algorithm output. Use them for that. The SQL row to thing is perfect. It's great for those many permutations where you have a lot of permutations. You don't want to check them all in integration tests. So you take that logic, you tease out the logic, make it into a unit that is easily testable, and test it as a unit test. Just don't do the test all units. Any function I write it as a unit. I write a unit test for that. You don't need that. Integration tests are what they're there for. Use the unit testing to test what are really testable units. Things that are mostly independent as units and make sense to test. And how do I ensure I write tests? Well, we have a very easy, at Applitools, quality is very important. How do I ensure that me and my team write tests? And the answer is very easy. Never run the microservice locally. If you write code, you want to check that the code you write is run. You can't run the microservice and use Postman to HTTP things and check that it works. You are not allowed to do that. Okay, that's rule number one. Never run your microservice locally. So how do you check that your code works? Easy. You write a test. So everything you write, if you really want to check that it works, you write a test. And those tests remain forever. And that is how we make sure that we write tests for our microservices. And it's a pretty good way. You don't want to write tests, you want to deploy straight to production, fine by us, but it's on you. And it never happens. Okay, what is the right mixture of unit integration and end-to-end? There are a lot of schools. There's the pyramid school, which is a lot of unit tests. This is true for monolith apps. I think for microservices, this is less true, as we talked about. So not a lot of unit tests, only make sense. A lot of integration tests like we've seen. They're really fast and very easy to write, and very, very few end-to-end, small end-to-end tests. The right mixture is, as we said, a lot of integrations. But if you can do a unit, tease out unit code that can be tested separately without a lot of mocks or with zero mocks, do that. An end-to-end, small end-to-end that tests just the microservice as a Docker container, just to make sure that the Docker image works, so write one or two, and we're good. And there are scenarios that can't be integration tested. Some really weird ones. We have those at Applitools. Do an end-to-end. And don't forget to write a big end-to-end that tests all the microservices together. But that is a subject of a really separate talk because it's a whole separate subject. How do we do that? Or do we need it at all? What about, a lot of people write microservices as controller, calls to service, calls to a DAL, a data access layer, or it's called a store or repository in some places. I'm not a huge fan because microservices are small. I don't need all those layers. So sometimes you do, okay? I have some where the store, the data access is very hairy. So I have those. And what I do is I test the store separately as a separate thing because it's complex logic. This is a good example of not testing the whole integration test, not testing the whole microservice, not only the whole microservice, but the store separately. So I'm not sure you can hear that. I'm pretty sure you can. But if you can, this is the original song. These boots were made for walking, and that's just what they'll do. One of these days, these boots are gonna walk all over you. And microservices, remember, made for testing. And that's what you should do, because one of these days, these tests are gonna help a lot for you. And I always finish testing talks. I don't have just testing talks, but if it's a testing talk, I always finish with the Litany of Fear by Frank Herbert Dune. Usually, I make everybody go, stand up and recite it with me. In this case, tough, so I will recite it myself. So please listen. I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. I will test my microservices. I will permit them to pass over and through me. And when they have gone past, I will turn the inner eye to see their path. Where the fear has gone, there will be nothing. Only my tests will remain. Thank you very much. Okay. Questions? This is questions time.
Yes, thank you very much, Jill, for this presentation. It was really impressive.
Thank you.
I can see that there are no questions right now in the chat,
Okay.
but if anyone has any questions or anything comes to your mind, just feel free to join the Slack channel I was mentioning before. We all are available there, so you can talk to Jill there as well. It is already on the screen. You can see the link there. So feel free to join it, and we will be also mentioning there our next meetups. So you will stay tuned, and also we will be sending there a feedback form. So shall we post questions on Slack, or Ante, if you have any question, just feel free to type it into the chat, and we can go through it right now. I can see a question there in the chat, so I'm just answering Ante Tomic. Yeah, and I will just finish so that there will be a feedback form posted into Slack channel. So if you can fill it in, it will be great. And we will now wait for Ante if he has any question right now, or if he continues in the discussion on Slack. So feel free, if anyone has any other questions, just type them in and Jill can answer them, I believe.
Yep, I'm here.
Yeah, no questions coming right now.
I'll be in the Slack channel for the next.
Yeah, I think that we can end it here right now. So thank you very much, Jill, once again for this awesome presentation. It was really a pleasure to have you here. And thanks everyone for joining once again. And see you hopefully soon. Bye.
Bye.